All right, welcome to the deep dive. Today we're diving into the fascinating world of prompt engineering. That art of getting large language models to do exactly what you want them to do.
And it really is an art, isn't it? I mean, anyone can write a prompt, right? But to really make those LLMs sing, especially for our Kaggle folks out there dealing with code and complex data, well, that's where the real skill comes in.
Absolutely. So if you're a Kaggler, you're trying to generate killer code, squash those pesky bugs, and come up with innovative solutions, well, that's what we're focusing on today.
We've got a fantastic white paper here that we're going to dissect, pulling out the most practical and powerful techniques you can use to level up your Kaggle game.
Our mission is clear: to equip you with the prompt engineering methodologies you need to succeed. We'll cover the basics, but then we're going to go deep, exploring techniques like chain of thought and React.
And we're going to do it all through the lens of your everyday Kaggle challenges. So this isn't just theory, it's about giving you tools you can immediately put to work in your competitions.
Perfect. Now, before we even start crafting those awesome prompts, we need to talk about something fundamental.
Yeah.
Configuring the LLM's output. It's not just what you put in, it's how you shape what comes out.
Right, and you have a surprising amount of control here. Let's start with output length, which might seem simple, but the number of tokens the model generates directly impacts costs, processing time. Those are real-world concerns, especially in a Kaggle notebook.
Yeah, if you're hitting those Kaggle output limits or need an answer quickly, just setting a low token limit in the model configuration might not cut it.
Exactly. Sometimes you need to engineer your prompt to be more targeted to get a concise response, like in the React technique, where you're aiming for quick, iterative actions.
Makes sense. Okay, let's move on to sampling controls. Now, this is where things get really interesting. We're talking about how the LLM actually chooses the next word based on probabilities.
You got it. And how we sample from those probabilities can dramatically change what we get back.
Okay, so let's break it down. What's this temperature thing all about?
Think of temperature like a dial that controls randomness. A low temperature pushes the model towards the most likely word, so you get predictable, deterministic output. It's almost like getting the model's best guess.
So if I need to generate some very specific code from my Kaggle kernel, like importing a library with the correct syntax, a low temperature is probably what I want.
Exactly. You don't want the LLM getting too creative with your import panda statement.
No, definitely not. But sometimes a bit of creativity is exactly what you need in Kaggle.
Absolutely. That's where a higher temperature comes in. It introduces more randomness, so you get more diverse and unexpected results. You might use this to brainstorm novel features or explore different algorithms, those what-if moments that can spark a breakthrough in your Kaggle project.
That's really cool. So low temp for precision in my code, higher temp for exploring new ideas. Got it. Now, what about top K and top P? These sound like ways to further fine-tune that word selection process.
They are. Both top K and top P, also known as nucleus sampling, limit the next word to only the most probable candidates. With top K, you're essentially saying, only consider the top K most likely options.
Okay, so a higher K means more variety in the output, while a lower K makes it more focused. And if K is 1, it's basically that deterministic best guess again, right?
Yeah, precisely. With top P, you're working with probabilities instead of a fixed number. It selects the smallest set of words whose probabilities add up to at least the value of P.
So a lower P makes the output more restrictive, while a higher P, closer to 1, considers almost all possible words. And just like with top K, a P of 0 is essentially forcing that best guess.
Exactly. The key for your Kaggle work is to experiment with these. Sometimes one works better than the other, and sometimes a combination is the sweet spot.
So how do all these settings work together? If I adjust temperature, top K, and top P, what happens in what order?
Great question. When all three are in play, the model first looks for words that meet both the top K and top P criteria. Then the temperature setting comes in to randomly pick from that filtered set based on their probabilities.
So it filters by top K and top P first, and then the temperature setting influences the final choice among those filtered words.
Yeah.
What if only top K or top P is set?
Then it just filters by whichever one is active. And if temperature isn't set, a word is just randomly chosen from those that pass the filter.
Interesting. So if I really need that super deterministic code generation for my Kaggle notebook, I should crank that temperature down to 0.
You got it. A temperature of 0 essentially eliminates the randomness and forces the model to always pick the most probable word. In that case, the top K and top P settings become less relevant.
Makes sense. And on the flip side, setting top K to 1 or top P to 0 also forces that single best guess, overriding the temperature setting.
Absolutely. And very high values for K or a P of 1 essentially let almost all possible words into the mix.
Okay, so with all these dials to play with, where do we even start? Any recommendations for our Kaggle folks?
The paper actually offers some excellent starting points. For generally coherent results with a touch of creativity, maybe when you're brainstorming model architectures for your competition, they suggest a temperature around zero point 0.2, a top P of 0.95, and a top K of 30.
Those are good benchmarks to keep in mind. What if I'm really pushing for creative output, like trying to come up with completely new data augmentation techniques?
Then you might bump those up a bit. Try a temperature of zero point 0.9, top P of 0.99, and top K of 40. That'll give you more variety and potentially lead to some truly out-of-the-box ideas.
Awesome. And what about when I need less creativity and more factual accuracy? Like when I'm generating that boilerplate code for a common Kaggle task?
For that, dial things back down. Try a lower temperature, maybe zero point 0.1, top P of zero point 0.9, and top K of 20.
Perfect. And what if I just need a single correct answer, like implementing a specific algorithm in my kernel?
In those cases, a temperature of 0 is usually your best bet.
Got it. Now, the paper also mentions something called the repetition loop bug. What is that?
Ah, the repetition loop bug. It's a real headache where the model gets stuck repeating the same words or phrases over and over again.
Sounds frustrating. How does that even happen?
It can actually happen at both low and high temperatures. At low temperatures, the model can get too predictable and get stuck in a loop, revisiting the same words. And at high temperatures, all that randomness can, by chance, lead back to a previous state, creating a loop.
So it's like the model is either too predictable or too random, and either way, it ends up repeating itself.
Precisely. The key is to really fine-tune those sampling parameters, temperature, top K, and top P, to find that sweet spot where you get creative and interesting output without falling into those repetitive traps.
Okay, so we've got a good handle on how to configure the LLM's output to get the kind of responses we need for our Kaggle work. Now let's dive into the heart of prompt engineering, the actual techniques themselves.
Let's do it. And the paper really stresses that crafting clear prompts is the foundation of getting great predictions from these models. Using specific techniques can further boost those results.
So where do we start?
The simplest form is what's called general prompting, or zero-shot prompting. You're basically giving the model a task description and some input without any examples.
So if I'm working on a Kaggle problem and need a code snippet to do some data preprocessing, I could just describe the task and provide the relevant data, and the model should be able to generate the code.
That's the idea. The model has seen a massive amount of code, so it should have a decent shot at understanding your request.
Makes sense. But the paper also emphasizes something really important: documenting your prompts.
Right. This is crucial, especially for Kaggle, where you're constantly iterating and trying to improve your solutions. You'll experiment with different prompts, and keeping track of what worked, what didn't, and why is essential for learning and getting better.
So a structured approach to documenting prompts is key. What if zero-shot prompting isn't quite cutting it? Maybe I need more control over the output format or need the model to generate something more specific.
Then you move on to one-shot and few-shot prompting. Here, you provide examples within the prompt to guide the model.
So if I need the output in a specific JSON format for my Kaggle submission, I'd show the model a few examples of the input data and the corresponding JSON output I expect.
Exactly. The model learns from those examples and gets a much clearer understanding of the task and the desired output format.
This seems incredibly useful for Kaggle, especially for tasks like extracting specific information from data or formatting your model predictions. But the paper also cautions about the examples themselves.
Yes, the quality and relevance of your examples are crucial. If you use poorly chosen examples, or if there's even a small error in one, it can confuse the model and lead to garbage output.
So garbage in, garbage out, as they say. And it's especially important to include examples of edge cases, those unusual situations that your code or model might encounter in the competition.
Absolutely. If you want your solutions to be robust and handle those unexpected scenarios, your examples need to reflect that.
Okay, so we've covered zero-shot, one-shot, and few-shot prompting. Now the paper moves into system, contextual, and role prompting. These sound like different ways to provide more high-level guidance to the LLM, which could be really powerful in Kaggle.
They are, and while they can overlap, each focuses on a slightly different aspect. System prompting is all about setting the overall context and purpose. It's like defining the big picture for the model.
So I might use a system prompt to tell the model, you are a helpful and efficient coding assistant for a Kaggle data scientist.
Exactly. Or you could use it to specify output requirements like output all predictions as a JSON object with specific keys.
That JSON example is really relevant for Kaggle. Having structured data in a predictable format is crucial for further analysis and creating those submission files.
Absolutely. The paper even notes that using system prompts to enforce JSON output can help limit errors and ensure the data comes back in a usable order.
Interesting. Now, what about role prompting?
With role prompting, you're giving the LLM a specific persona or identity. This can really influence the style and tone of its responses.
So if I'm working on a Kaggle project that involves generating documentation, I could prompt the model to act as a senior software engineer or a technical writer to get more tailored and effective documentation.
Precisely. It's about giving the model a clear understanding of the perspective you need it to take. You can even get creative with it. Maybe you want a humorous but technically accurate style when explaining your code, or a more formal and rigorous style for your competition write-up.
That's really cool. Now, contextual prompting seems to be more about providing specific background information that's relevant to the task at hand.
Right. It's about giving the model all the details it needs to understand the nuances of your specific Kaggle problem.
So if I'm asking the LLM for help debugging my code, I wouldn't just say, my code's not working. I'd provide the specific code snippet, the error message, and the libraries I'm using.
Exactly. The more context you provide, the more relevant and helpful the model's response is likely to be.
This is really starting to feel like a powerful toolkit for tackling Kaggle challenges. Now, the paper introduces step-back prompting. What's that all about?
Step-back prompting is a clever technique where you first ask the LLM to answer a broader related question before getting to your specific task. It's like priming the pump, getting the model to activate its knowledge base before diving into the details of your Kaggle problem.
So if I'm trying to come up with a novel feature for my competition, I might first ask the LLM about general principles of feature engineering before prompting it for specific ideas related to my dataset.
That's the idea. It can lead to more insightful and creative outputs, and the paper even suggests it can help mitigate biases in the LLM's responses.
Now, we get to a technique that's been getting a lot of attention. Chain of thought prompting. It seems particularly relevant for those multi-step reasoning problems we often encounter in Kaggle.
It is. COT is a powerful technique for boosting the model's reasoning capabilities. The idea is to prompt the model to explicitly generate intermediate reasoning steps before giving the final answer or code suggestion.
So instead of just getting a solution, I also get to see the model's thought process, how it arrived at that solution. That could be incredibly valuable for understanding the LLM suggestions and making sure they're actually sound.
Absolutely. The paper highlights several advantages of COT. It's easy to implement. It works well with readily available LLMs, it makes the reasoning process transparent, and it seems to improve the robustness of the reasoning across different LLM versions.
But there's a trade-off, right? It uses more tokens, which could mean higher cost and processing time in a Kaggle environment.
That's true. Since the model is generating those intermediate steps, the output will be longer. The paper shows a great example of code using a math problem. A direct prompt gets the wrong answer, but when prompted to think step by step, the model gets it right.
That's a compelling example. And the paper also shows how combining code with a single example can further improve the results.
Right, they call that single-shot code too.
So CoT seems incredibly valuable for those Kaggle tasks that involve complex logical reasoning, like debugging intricate code or figuring out why my model's performance is stuck.
Definitely. And the paper even suggests its applicability to code generation and creating synthetic data.
Now, building on that idea of getting more reliable answers from the model, there's also self-consistency. What's that about?
Self-consistency takes code a step further. You get the model to generate multiple different reasoning paths for the same prompt, and then you choose the most consistent answer across those paths.
So it's like getting multiple expert opinions from the model and then going with a consensus. That makes a lot of sense for improving reliability, especially for those crucial Kaggle submissions.
Exactly. It can be a bit more computationally intensive, but for high-stakes tasks, it can be a worthwhile trade-off.
Now, we move on to a technique with a very intriguing name, Tree of Thoughts, 2T. The name itself suggests a more complex and branching approach to problem solving, which seems perfect for those really open-ended Kaggle challenges.
It is. Tree of Thoughts is a generalization of COTI, where the LLM explores multiple reasoning paths simultaneously, rather than just a single linear chain of thoughts. It's like the model is branching out, exploring different avenues, and backtracking if needed, just like we do when we're tackling a tough problem.
So for those really challenging Kaggle problems where there isn't one clear solution path, 2T might be the way to go.
Absolutely. And if you look at the figure in the paper that contrasts COT and 2T, you can really see how 2T allows for much more exploration and creative problem solving.
Okay, we're nearing the end of our prompt engineering journey, and we arrive at a technique called REACT, Reason and Act. This one seems particularly exciting for Kagglers who want to use LLMs to interact with external tools and data sources.
You got it. REACT stands for Reason and Act, and it's all about combining the LLM's reasoning capabilities with the ability to use external tools like search engines, code interpreters, or even APIs.
So the LLM could actually execute code in my Kaggle notebook, analyze the results, and then use that information to guide its next steps. That's incredibly powerful.
It is. It's like the LLM is becoming an active participant in your Kaggle workflow, not just a passive code generator. The paper shows an example using LangChain and Vertex AI, where the model uses search to find information and then uses that information to make decisions.
And then we have automatic prompt engineering, APE. The idea of an AI writing prompts for itself is pretty mind-blowing.
It is. APE is a technique for automating the creation of effective prompts. You essentially ask the model to generate various prompt variations for a task, and then you evaluate those variations based on their performance.
So I could use this to automatically find better prompts for code generation or data analysis in my Kaggle project.
Exactly. It could save you a lot of manual experimentation and potentially uncover prompts that you wouldn't have thought of on your own.
Now, the paper also dedicates a whole section to code prompting, which is obviously a huge area of interest for Kagglers.
Absolutely. Prompt engineering isn't just for natural language tasks. It's incredibly useful for anything code related.
So let's break it down. What are some of the key applications of code prompting in Kaggle?
Well, they start with prompts for writing code. They show an example of prompting for a bash script. The key takeaway here is that LLMs can really speed up your code development, but always review and test the generated code carefully before relying on it.
That's crucial advice. Don't just blindly trust the model's output, especially when it comes to code that could mess up your Kaggle environment.
Right. Then there's prompts for explaining code. They take that bash script and ask the model to explain what it does, which it does quite well. This can be super helpful for understanding unfamiliar code or collaborating with teammates in Kaggle.
Definitely. It's like having an instant code explainer on hand. What about translating code? That could be really useful if I find a cool algorithm in a language I'm not so familiar with.
Absolutely. They show an example of translating that bash script into Python. Again, it's important to double check the translated code and make sure it works as expected.
And last but not least, prompts for debugging and reviewing code. This is something every Kaggler has struggled with at some point.
For sure. They give an example of a broken Python script and show how prompting the LLM with the error traceback can lead to it identifying the error and suggesting a fix. And even cooler, it can sometimes suggest ways to make your code more robust and efficient.
That's amazing. It's like having a coding buddy who's always there to help you debug and improve your code.
It really is. And the paper also briefly touches on multimodal prompting.
Ah, yes, using inputs beyond just text, like images or audio. That's a whole other level of prompt engineering.
It is, and it's still an evolving area. It could become increasingly relevant for Kaggle competitions that involve multimodal datasets.
Okay, we've covered a ton of prompt engineering techniques, and it's clear they have huge potential in Kaggle. But to really master this, we need to talk about best practices.
Absolutely. The paper lays out some fantastic best practices that can really elevate your prompt engineering game. And the first one is so simple but so important. Provide examples.
One-shot and few-shot prompting, we've
Right.
talked about it, and it's a powerful way to teach the model what you want.
Right. And the next best practice is to design with simplicity. Keep your prompts clear, concise, and easy to understand, both for you and for the LLM.
So get straight to the point with your coding requests, avoid jargon, and use strong action verbs to tell the model exactly what you want it to do.
Exactly. And remember to be specific about the desired output. If you need your predictions in a particular CSV format, tell the LLM. Don't leave it guessing.
And this one's interesting. Use instructions over constraints. So in Kaggle, instead of saying, don't use this library, I might say, Write code that only uses these specific libraries.
That's a great example. Focusing on positive instructions can often be more effective than relying on constraints. And speaking of practicalities, remember to control the max token length to stay within those Kaggle limits and manage processing time.
Right. And to make our Kaggle prompt libraries more reusable and maintainable, we should use variables and prompts.
Absolutely. This allows you to create dynamic prompts that you can easily adapt for different datasets, models, or tasks without having to rewrite the entire prompt each time.
And of course, experimentation is crucial in Kaggle, so we should experiment with input formats and writing styles.
Definitely. Try phrasing your prompts in different ways as questions, statements, instructions, and see what works best for each specific task. And if you're using few-shot prompting for classification tasks in Kaggle, mix up the classes in your examples to prevent the model from getting biased.
Great tips. And given how quickly AI is evolving, we need to adapt to model updates. New models and features are constantly being released, and staying ahead of the curve can give you a real edge in Kaggle.
Totally agree. Keep an eye out for updates and experiment to see how you can leverage new capabilities in your projects.
And speaking of experimentation, we should also experiment with output formats. For Kaggle, structured formats like CSV or JSON are often the way to go.
Especially for those data-heavy tasks in Kaggle, using a structured format can make your life so much easier. And if the LLM doesn't quite get the JSON format right, there's even a section on JSON repair using libraries that can automatically fix those errors.
That's a real lifesaver. And if you're working with structured data in Kaggle, you might want to explore working with schemas to define the expected format of your data for the LLM.
Using a JSON schema can really help the model understand your data and reduce those frustrating misinterpretations.
Collaboration is huge in Kaggle, and the paper encourages us to experiment together with other prompt engineers.
Bouncing ideas off each other and sharing successful prompt strategies can really accelerate your learning and lead to breakthroughs. And for those using Kaggle, there are specific cut best practices to keep in mind.
Like putting the final answer after the reasoning steps and setting the temperature to 0 for those logical tasks.
Exactly. And finally, perhaps the most crucial best practice of all. Document the various prompt attempts. Keep detailed records of everything you try, the results you get, and your feedback on each prompt.
This is so important. It allows you to track your progress, understand what works best, and debug issues in the future. And if you're using a platform like Vertex AI Studio, saving and linking your prompts can save you a ton of time.
And if you're integrating prompts into your code, the paper gives specific advice on how to manage and test those prompts effectively within your code base.
It all comes back to the fact that prompt engineering is an iterative process. You're constantly learning and refining your approach to get the best possible results.
Exactly. It's a journey, not a destination.
Well, we've covered a massive amount of ground today, exploring a wide range of prompt engineering techniques and best practices, all through the lens of Kaggle.
We started with the basics of zero-shot, one-shot, and few-shot prompting, then moved on to techniques for providing context and guidance like system, role, and contextual prompting.
We explored those advanced reasoning techniques, step-back prompting, chain of thought, self-consistency, tree of thoughts, and even touched on React and automatic prompt engineering.
And we dive deep into the world of code prompting with all its exciting possibilities and crucial considerations for Kagglers.
And of course, we can't forget those invaluable best practices that can really make or break your prompt engineering efforts in Kaggle.
It's clear that poorly crafted prompts can hold you back, even with these incredibly powerful LLMs. But mastering these techniques and best practices can give you a real advantage in the competitive world of Kaggle.
So to all our Kaggle listeners out there, especially those working on those final capstone projects or tackling those tough competitions, take these techniques and best practices and run with them. Experiment, iterate, and push the boundaries of what you can achieve with LLMs.
And as we wrap up, think about this. Prompt engineering is a rapidly evolving field. It's changing how we interact with AI, especially in technical domains like Kaggle. What exciting new possibilities will emerge as these models become even more capable and we get even better at guiding them?
Food for thought. Thanks for joining us on The Deep Dive.
It's been a pleasure.